AI is artificial intelligence and anesthesia. Artificial intelligence is a broad concept of machines designed to understand and perform tasks on their own in a smart manner. It involves programming of computers to simulate cognitive functions of human mind, such as pattern recognition and problem solving. One of the simpler ways in which a computer can be used in anesthesia is to design a servo system, for example, to maintain a bispectral index within a specified range by continuous assessment of and adjustment of the infusion rate of anesthetic agents. Various subsets of AI are machine learning, deep learning, robotics, neural network, and computer vision. Machine learning involves collection and analysis of the data by the computer with a focus on model development and pattern recognition to make intelligent predictions. And machine learning can be of supervised learning, unsupervised learning, and reinforcement learning, which is useful to understand the applications. While pattern recognition becomes unsupervised and supervised applications include training and testing of data sets. Reinforced learning involves continual feedback for the algorithm modification. The ultimate goal of AI-based systems is to make access to real-time patient data and information from medical publications and to integrate the various types of data from the system and learn various relationships producing each information. And it is necessary to combine accuracy with the explanations in healthcare settings. And even more in anesthesia, it helps in understanding mechanisms and consequences and critical scenarios, and which of these consequences can be serious. And artificial intelligence helps in understanding these mechanisms. And computers, which are said to become indispensable tools for the delivery of anesthesia and also for decision making and in day-to-day clinical care and OPD. And regarding robots in anesthesia, a robot is any mechanical system which is capable of interacting with the environment according to directed interventions. And robots are designed to support clinicians by automating tasks and offer pertinent recommendations to aid in decision making based on the particular clinical scenario. And there are two types of robots, mechanical robots and pharmacological robots. And the first generation open loop pharmacological robots were the target controlled infusion systems generated. And the software has an inbuilt pharmacokinetic models of different drugs based on which they deliver specific loading doses to achieve specific plasma drug concentrations rapidly and to maintain a steady state. And they display estimated plasma and effect site concentrations, which may differ from the actual concentration, especially in those who display different racial characteristics and different anthropometric features. And in closed loop systems, a goal for a measured variable is set up by the operator, and the drug delivery is adjusted to make a gap between the set goal and actual variable as small as possible. And there are initial models, single input, single output systems, and there are recent advances, which is multiple input, multiple output systems. And the anesthesia parameters targeted by the single input, single output systems include hypnosis or muscle relaxation, which is nerve stimulator guided, which acts as feedback for drug delivery. And there is also an analogous code described for measuring pain assessment during the general anesthesia, which is calculated by deviation of the patient's target heart rate and the mean arterial pressure. And there is also an advancement in automated anesthesia delivery and closed loop fluid management in the multiple input, multiple output system, where two independent closed loop systems were used for hypnosis, analysis, and fluid management during major vascular surgeries. And also it enables the feasibility of combining fluid administration along with appropriate vasopressor use in guiding perioperative care. And regarding mechanical robots, which are most commonly used in regional techniques and intubation techniques. And the examples are Magellan system for regional anesthesia, which uses a block needle. And for intubation, Da Vinci and Kepler intubation system, which uses a single robotic arm. And regarding the current trends in AI in anesthesia, artificial intelligence is also used in pre-anesthetic evaluation and also in intraoperative anesthetic care and also used in post-operative care. And regarding clinical decision support system, which is a knowledge based, which has a built-in algorithm or also has non-knowledge based. And preoperative cognitive robots, which helps in detection of abnormal lab findings, also ensures drug compliance and conducting of regular checklists. Intraoperative robots, which is used for identification of appropriate prophylactic antibiotics and latest recommendations of smart alarms and dosage schedules and billing sections and various purposes. And regarding the issues and disadvantages of AIR, there are a lot of discrimination and bias and privacy and security issues, and there are lack of transparency and accountability and lack of regulatory processes and access to healthcare and the ethics involved. And applications of AI in anesthesia are pre-surgical evaluation, which is helpful in pre-operative management and planning, and which helps in preventing drug errors, which is the most important part. And anesthetic dosage optimization can also be done. And early detection of complications like hypotension, hypoxia, and automated monitoring and automated anesthesia dosing, and predicting the patient outcomes and post-surgical ICU admissions. And it helps in real-time decision support and crisis management, and also in pain management and training and education and research and analysis and resource allocation also is helpful. Thank you, sir.
It is also read from the earlier notes and